one thing before we get started, I can't actually see the chat, so I'm just going to kind of stick with the presentation and then totally hang out and answer all questions at the end, if that's okay with everyone. I do want to say that I do have the Edmonton Slack open on my other machine, so if you actually post into the Meetup Ruby, I can try to answer questions there while we're going too, if that helps. But otherwise, thanks so much for letting me speak today. I want to talk about the Git Rebase workflow and how to level you up as engineers so you can write your Ruby code or your JavaScript code with better confidence and in a way that communicates what you're trying to build to the rest of your team members. So without further ado, I just want to kind of go into the key benefits here and lay this out. By the way, these slides have links to articles at the bottom, and I'll get these slides up to all of you at the end, so don't stress out if you're trying to take notes. There's a lot of content in here. It's pretty technical, and Git itself is quite obtuse to begin with, so we'll try to make this as entertaining as possible. But the key benefits of Git is that with a rebase history, you can keep it very linear, right? One commit after the other, very, very linear, very easy to read, very easy to understand. This makes it, like I said, readable, which is really important for your team members to understand what it was that you were thinking at the time that you were building your implementation, and then also to be able to debug it. All three of these together make for a really easy to understand repository and just a history of how all of you as team members evolved the code base over time. So before we get into Rebase, though, we kind of need to stop back and kind of do a brief history between merge and Rebase. So to start this off, I just want to kind of compare here Rebase and merge really quickly and kind of walk through both. So if you look at this kind of diagram here, if you consider each of the circles being commits and each of the colors being different authors, we can kind of walk through this together, looking at the differences in code that's being committed. Now, it's the same code in each case, right? On the left, we have merge, which is a little hard to grok. And then on the right, we have Rebase. And if we walk through this together, right, seeing the same author do the same commits, but the author on the left actually is doing a merge workflow, and then the authors, on the right are actually doing a rebase workflow. And you can quickly see that there's a big difference here in trying to understand who did what when. Granted, this isn't terribly complex, but it can get out of hand pretty quickly. So let's talk about merge first for just a moment. If you look at another way to look at this is if you have the master branch on the left here, and you have these different authors committing code in time, and then you have Mariana over here on the feature branch, and she checks off code based off of Ozzy's commit. She does some commits, and then she finally merges it into master after Vivian. And that's preserved in history in time, right? The date timestamps, they're not modified, the SHAs are not changed, everything's just kind of preserved as is. And that's a default workflow when you first start using Git and just out of the box, right? So let's take a look at where this can kind of start to go a little awry. So here's a workflow where this team is making commits, but they're merging them back into master, right? But what's happening here is it's just very simple merge bubbles. They're kind of going, somebody's branching off a master and then merging back into master with their feature branch at the end. Pretty simple, right? Not too hard to follow. It's a pretty easy, just in and out bubble structure. But what happens if a team goes really crazy with a merge workflow, and they're just merging all over each other? They're merging into their feature branches. They're merging onto master. They're just going crazy. Well, here's a repository and a team that I had to work with one time that did exactly this. And you can see as we go back in time and we're trying to trace through who did what, this gets insane really fast, to the point where I can't actually figure out who did what when. Like, we could print this out through a big printer, put it on the floor, and try to map out the different colors of authors there and figure out who did what when, but that's not something I want to spend my time doing as an engineer. So another way to look at this is Git merge is essentially, just this, two armies merging the commits all together, and it's just total chaos and a complete mess. So let's not do that. And let's focus on more of a rebase workflow. But first, before I go though, I want to kind of show you how those logs were made, just in case you were curious. So when I was showing you that Git graph, right, you can do this from the command line by just using git log. and then passing in the graph option, and then do a pretty format, a pretty print format where you open up yellow for the SHA and then reset the color, open up green for the committer date, and then reset the color. So FYI, just in case you were curious how those graphs were made. Okay, so I've talked about merge, but let's talk about rebase for a little bit. So rebase is exactly what it says on the tin here, which is it's just reapplying commits on top of the tip, which in this case would be master in a very simple structure, or if you're using the new main terminology, which is actually a good thing to do. So if we look at the same commits that we were looking at before with Mariana, we have the same authors, we have the same commits, but notice that Mariana rebased in this case, and so she just nicely lays in front of Vivian in this case. Same code, same commits, just done a different way through rebase. So if it helps graphically, this is a nice way to look at this if you've never really kind of sort of mapped this out in your head, what this looks like graphically, where you have master, which is the blue commits, right? You have a feature branch that branched off of that, and then you just replay those on top in front of master. If it helps, this is another way to visualize the same flow, right? You could, instead of thinking of replaying the commits on top of master, you could just think that your feature branch is nicely slid in front of master. So all your work just happened and got applied afterwards, which is a nice way to think about rebase if you've never thought about that graphically before. So what does a rebase workflow look like in a project that is well maintained with a team that is committing often and rebasing into master? Well, let's kind of take a stroll through a project here that's been maintained over several years. And you can see as we go back in time here, right, this is going to start speeding up over months, over years. And you're going to see that this never bubbles out, right? We're using the same git log graphing here through the commit structure of the entire repository. And you can see that it's been rebased the entire time. One commit just follows one after the other, very sequential, very linear, very easy to debug. So let's talk about this workflow, right? If we kind of look at this from the command line and kind of walk through the commands, what this kind of looks like in kind of a typical workflow is, you'll start your day, you'll synchronize, you'll pull from master, which git pull, by the way, is just two commands in one. It's really doing a fetch and a merge at the same time, in case you were not aware. And then what you'll do is you go ahead and you'll switch to your feature branch. So in this case, we'll switch from master. We'll create our new feature branch. We'll call it example, and we'll track the changes on it. Track, by the way, I highly recommend always using. If you've never done it before, it just sets metadata in your local Git config to name that branch and know the remote branch that you're pushing to. So you don't have to keep typing in example every time you push that example branch to master or to the remote repository, sorry. So then you commit some code, right? You commit, you keep working on your implementation. And finally, you're actually ready to actually submit this for a code review with your team. So you might you might have been heads down for an hour or maybe two, and you're like, hey, I should actually switch back to master. I should pull to see what the changes are from the team so I can get the latest changes, make sure there's no merge conflicts with the work that I've been doing. And then you'll switch back to your master branch. You'll pull master into the changes from master into your feature branch. At that point, you are creating a merge bubble because you're merging master into your work. And you'll address any merge conflicts, any kind of issues that might have come up, and then you'll go ahead and push that up to the remote branch, or sorry, to the remote server. Okay, so that's the merge workflow. So if we contrast this with the rebase workflow, let's kind of look at the subtle differences just to change from a merge a merge workflow to a rebase workflow. So you'll start by, pulling your changes. Now, remember, it's git, fetch, and pull at the same time, but I'm going to do a couple things that are different here. First of all, I'm going to fetch, and then I'm going to prune. Prune, by the way, I highly recommend always using, and I'll show you how to configure this later so you don't have to type it out all the time. But that'll prune all the branches that have been deleted or merged into master on the remote repository so that you don't maintain those locally, because it's not fun actually having a whole bunch of local branches that you have to sift through. So just let Git do all the work for you and just prune those things. If the remote repository has got rid of them, go ahead and get rid of them locally and let Git do that. And then oops, I went a little fast, but the next is rebase, and that's it. That's the key right there. Is git pull -- rebase switches from a merge workflow to a rebase workflow. Then I kind of went too fast through my slides there. Sorry about that. But yeah, switch to a Rebase workflow. Then you'll go ahead and start creating and working on your feature branch, right? Nothing really changes in that workflow, except when you start to push this time. So you'll come down and you'll do a pull, right? You'll switch back to master, pull rebase the changes from the team, right? From the remote repository. You'll go ahead and switch to your example branch, but this time you won't pull from origin master. You'll actually rebase from origin master. Again, the subtleness is just with the -- rebase option. And then finally, when you go to push these changes, you're going to do a force with lease and then a force if includes. Force with lease basically is a nice way if you've been pair programming with a colleague. And the nice way to describe this is, let's say that you forgot to communicate properly. I don't recommend doing this kind of workflow, but let's say that you did do this workflow, and you went to grab lunch. Your colleague went ahead and started working on the feature branch even further, and they pushed up changes. Well, if you were to do a force push, which is the default way when you're rebasing, because the SHAs have changed, so you have to force push those changes up. The force with lease allows Git to at least check to make sure that that hasn't diverged at all, that the commits on the remote branch don't match what you have locally, and it'll halt that so you don't accidentally override your colleague's work. So that's why I always highly recommend turning that on by default. The force if includes actually is another safety check that's pretty new in the recent version of Git, where it just checks to make sure that the remote repository, the SHAs in the code that's on the remote repository, you still have at least a reference of that locally in your local branch. So it's another safety check, another safety valve to make sure that you don't accidentally overwrite somebody else's work. But usually when you're in a Rebase workflow, you're generally just working on your own feature branch, and if you're pairing with somebody, you're usually kind of screen sharing, doing it that way. That's the recommended workflow that I always recommend. But if you're not, these are good safety valves to have on. And I'll show you how to configure some of these a little bit later so that you don't have to always type them. So let's jump into some quick tips, those configuration tips that I was talking about, and kind of show you how to set that up. So the first thing you want to do is when you're pulling, right, that rebase true, right? When we were saying git pull -- rebase to do the rebase workflow, well, in your global Git config, you can actually set this to true, and that'll prevent you from typing that each time. So you can just type git pull, and it'll just rebase automatically for you. So highly recommend turning that on. By the way, from the command line, if you were just to run this from the command line, do a git config global and then pull rebase true. That'll set your global configuration, so it just turns that on automatically for you. The other thing that I'd highly recommend is you can also do rebase as true. That'll turn on rebasing. But if you set it to merges, it's like an advanced technique that if you're working in a team that's kind of a hybrid, they're kind of doing half rebase, half merge, this will allow you to rebase even with some of those merge bubbles and handle them gracefully so that you don't have to kind of sift through them yourself when you're doing the interactive rebase. Highly recommend turning this on as a default too if you just want to level up a little bit further. You can leave it as true, but I would recommend merges if you can. The other thing I was talking about in your global Git configuration, right, is fetch prune. Well, if you don't want to type that out all the time, which I highly recommend don't spending the time working harder than you have to, you can just do git fetch, and if you have this configured globally, it'll just automatically do that for you each time. So I highly recommend turning this on, whether you are a rebaser or just a merger, just turn it on regardless. And again, here's the command line for actually enabling that. So Git just writes that to your global Git configuration for you. The last one I wanted to talk about was that force includes, right? So if you turn on push and you put this in your global Git configuration, that'll ensure that you always have that force includes check when you're doing a rebase. And again, you need to be running Git 2.3.0 or higher, which is actually at the time of this talk is the most recent version. And again, what that is doing, right, is it's chopping off the force includes. So you'll just have to type force with lease. Unfortunately, force with lease, there's no global configuration to turn that on yet. I'm hoping the Git team will change that in the future, but this will save you some typing. And again, here's the command line for enabling that if you're curious. All right, so now we've gotten kind of looked at the merge versus rebase. We've kind of talked through the configuration options in which to kind of speed up your workflow. But let's spend some time actually walking through interactive rebase together. So the way to kick that off, right? You're working in your workflow, you're pulling in your changes and you want to rebase. You want to rebase off of changes that have happened upstream. Maybe you want to do, well, actually I have to step back a little bit. It's not so much the changes that you're pulling down from upstream, it's actually changes that you want to edit or refine locally on your feature branch, where you just want to interactively rebase the commits that are on your feature branch themselves. And so I'm going to walk you through what that looks like. But before we do that, I want to talk about how interactive rebase can be used. So by default, usually you just interactively rebase off a master. And I'm typing it out long form here, but you can just type -I for the shorthand version. And what that does is this pops up this kind of editor into your IDE or whatever your default editor is, and it's going to look a little something like this. Might be a little scary, kind of daunting at first when you first see it. But what it's doing is it's saying, hey, look, you have 3 commits here. What do you want me to do with those? And then it's trying to show you that, hey, I'm going to try to attempt to rebase this SHA onto this other SHA. And then, by the way, if you forgot what you can do with me as the rebase editor, here are the commands that I'll take if you want to give them to me. I'll do something interesting with them. So we're going to talk through all of these, except for the last 3. Those are actually kind of special. They've been added recently into Git. But they deal with more of a merge workflow, and the purpose of today's talk is to be focused on rebase only. So before we get into those commands, though, I do want to show you how you can interactively rebase through a couple different mechanisms. First off, you can rebase by the @ and then tilde a number. So that means you can go back a certain number of commits when you rebase. The longhand form for that is head, so you can type head instead of @ there. You can also interactively rebase by a branch. So like I was showing you in the beginning, you can rebase off a master, but let's say that maybe you're in a nested branch kind of structure where you've pushed up code for your feature branch, you've got it up for review for the team, but then you kind of need to branch off that branch in order to keep working because you have more things you want to do with that code, but you're waiting for your team to review it. This gives you that outlet. And so you rebase off of whatever your feature branch name is and just rebase that way. It's a pretty advanced technique, but it comes in really handy if if your team is actually a little slow or distracted and they can't actually give you a good code review fast enough. This allows you to keep working off of the changes you've already pushed up for review in a nice fashion by just specifying the branch that you want to rebase off of. The other thing you can do is you can rebase by a tag. So if you've versioned a project or deployed like version 1.0 of your repository, this would allow you to basically work off that tag because maybe you're trying to work on a hotfix or a patch of some sort. I don't use this often myself, but it is really handy if you needed to actually work off of a tag, get a fix put together, and then release like a patch release. The other thing you can do is you can rebase by a particular SHA. So like I was showing you earlier with numbers, where you can go back a certain number of commits, you can actually just look at your Git commit history on your feature branch, pick the SHA that you want to rebase to, and just rebase to that SHA. Which is another handy technique to save you some time. This one here is a feature I don't use often myself. I just want to point it out that you can actually interactive rebase off of upstream. So the syntax for this is just @ and then the brackets and then upstream. That allows you to rebase off of anything that's happened off your upstream remote branch. So just FYI, pointing that out. And then this last one is one of my personal favorites. This is amazing. This rebases to root, but this comes with a huge warning. Wondering why am I even teaching you how to rebase to root? Because it's the very first commit of the entire repository. And you might be thinking, hey, this is pretty bad. Well, actually, it has a really good, useful technique. And the thing I love about it most is when I'm trying to work on a repository that maybe I'm going to open source for the first time, and I want to get all my commits in a nice fashion before I actually publish that to the world for other people to contribute and give feedback on. This gives them a nice clean history in which they can give feedback or just start with, right? Just figure out how to clone the repository, get up to speed really quick, and then start contributing. Also really useful for private projects that you're going to share internally with your team. You can interactively rebase from the very first commit of the repository and just make those really nice and well put together so you can share with your team later so that people can collaborate. Well, the one thing is this is great if you've done it on repositories that haven't been shared with anybody, but once you've shared it with your team and you're collaborating with others, you never ever want to do this because it'll change all the SHAs. And it's not necessarily disastrous, but your team's not going to like you because you're going to have to force everyone to reclone the repository because all the SHAs have changed. So don't do this on a repository that's shared. So one last advanced technique that I want to take you through is when you're interactive rebasing, some commands actually don't require you to actually pop up the editor each time you're rebasing. That can get kind of cumbersome as you're working through a really fast workflow. So the trick to do that is to actually disable it. This might seem counterintuitive because you're telling Git Editor true, but that basically just fakes Git out so it doesn't pop up the editor, and then you can do an interactive rebase without the editor entirely. The reason this comes in handy is if you're doing fixups or any kind of Git rebase technique that basically doesn't require any interaction from you, the author. This is a nice way to just kind of jettison that and rebase really fast. I use this a lot because I'm a heavy fix-upper, so this comes in handy really quickly. So I just want to point that out as an advanced technique as well. Okay, so we've walked through interactive rebase. Let's actually talk about these commands so you can actually see some of this in action. So what we're going to focus on here is these commands again. And I'm going to point out how these work. So you can type them out. You can say pick, reword, edit. You can type those out, or you can use just shorthand. You can just use the single letter. And I'll walk you through each one of these here so you can kind of get a sense of how these work if you've never seen this before. So the first one is pick. It's the default thing you get when you're in the editor, and it can seem kind of boring, actually. Doesn't seem like there's a whole lot to it. But pick actually has a really cool special power. And what it is that you can change the order of these. And the reason that's important is that if your commits are atomic, meaning implementation plus spec, and it doesn't touch other files, they're very, very atomic. You want to keep your commits always small, very atomic in that regard. You can easily move these around because they're not touching each other, so you won't have merge conflicts. And the reason that's important is because you can tell a story. Each commit that you add to the repository, right, is like a page in a book. You're just kind of turning the page to figure out like, oh, okay, on page 1, I started with this initial implementation, then I added documentation, and then I fixed the JSON schema. Pretty cool. That's a nice way to see like how the thought process was formed, how the implementation was built. So if you do those out of order, now through interactive rebase, you could just change the order of these picks and actually tell a more compelling story. So in this case, if I wanted to swap these two commits around, I would just magically change those. You can see the SHAs are different in order now. The fix of the JSON schema happened before I actually did the initial implementation. And so now I'm telling a different story on how this came to be. The other command you can use is reword. Reword kind of does what it says on the tin there, which is I'll pick one of these commits, right? I'll change pick to reword in this case. And then when I save that and close it, the interactive rebase editor, that, this command here that you're giving to it, when you save and close that, Git will then actually pop up and give you the commit message for that commit. So in this case, right, added documentation, we're going to see the subject and we're going to see the body. So in this case, we can rename the subject to something that's a little bit easier to understand, kind of the what of the message. And then we can also edit the body if we want to too. What's really important about this is in a commit message, a really good commit message, it's always the what that explains what it is that you're adding to the code base. And then the why is your body of the commit message, which supports the what. And it helps explain why you're doing what you're doing, which is so valuable in a code base, not only for your future self, but for your fellow colleagues, especially if you're not around for them to actually collaborate with you. It's kind of like they can have this conversation with your past self to understand why you did what you did. And that's really important. So if we do a git log in a pretty format now of those commit messages with it reworded, you'll see that the second commit message here has been nicely reworded now. So it tells a more compelling story. The next command is edit. This one's a little trickier. I can't show you all of it, but I will give you kind of a high-level overview. It works the same way as all the other commands, right? You'll pick one of the commits that you want to edit. You'll change that to edit. And then what's going to happen is the Git Rebase Editor is going to halt at that commit. It's going to allow you to not only edit the commit message, but you can edit the implementation. The reason this is so powerful is it allows you to go back several commits back in time on your feature branch and fix a bug that you saw in your commit in your implementation just by applying the fix of the bug, amending that commit, and then using Git interactive continue to finish the rebase. And I'll show you how continue and the other stuff works a little bit later. We'll talk about that in a little bit. The other command is squash. The way squash works is you can kind of pick 2 commits here, in this case, right? We'll go ahead and rename those to squash. And what we're going to do is we're going to take those 2 commits and we're going to squash them into the very first commit, that added initial implementation commit. So it's going to combine all the implementation details in a single commit and then allow you to edit the commit message, but it's going to squash all the commit messages from all 3 commits here into one commit message. What that looks like then is you're going to get something like this. Now, I've seen a lot of teams actually just say, oh yeah, that's it, I'm squashing it and that's it, I'm done. Please don't do that. This is really hard to read because you can see that we have 3 subjects here. We have 3 bodies and they're all trying to say different things. And this is really hard to read as one commit message, right, that we're squashing into one. So what we should do is clean this up. Let's just get rid of the fix of the JSON, right? Because we're squashing 3 commits into one. We don't actually have to tell anybody that we had a bug there to begin with. So we'll just throw that out and make it magically look like we fixed it to begin with, and nobody's none the wiser. So we'll just tear that message out. Now we're getting there. We're getting a little cleaner now. The one thing is we don't really actually need to explain table of contents in this case because we're adding the initial implementation. So let's focus on that. So we'll just chop that out. It's getting a little cleaner now. We're focusing on the initial implementation, but these 2 paragraphs here actually need a little bit of work. So we're happy with the subject, but we're not so happy with the body. So we'll just rip this sentence out and we'll reword it this way so that we added the initial implementation, which is the subject, right? And then in the body, we'll just say, hey, look, this is our first working implementation. And by the way, there's a README that was auto-generated with the tosser gem. Pretty cool. Now we've got all 3 commits down into one. It's just one commit that says added initial implementation, and it's nice, short, and sweet. And nobody knows that you had a bug to begin with. Pretty cool. So that's how you can use squash. Now, the next one up is actually fixup, which is actually one of my personal favorites. I use it a lot. And the reason why it's so cool is it's a nice way to fix up commits back in time. If you don't want to actually do a squash or go back and do an edit, you just want to actually point out a particular commit that you want fixed and then let Git do the rest of the work. So the way that works is just like squash. You'll change pick. In this case, you pick which ones you want to fix up, and then you'll change it to fix up, and then you'll move the fix up to the commit that you want to fix. So in this case, we're changing that last one, the fixing of the JSON schema, to a fix up, and then we're just moving it up to the commit and then added initial implementation, and that's the thing that we want to fix. Just like in our squash example, but in this case, remember, in the squash example, we had to like edit the commit message and get rid of the reason why we were fixing the JSON schema. In this case, we just want the implementation fixed. We don't actually care about the commit message, so we'll throw the commit message out and we'll fix the initial implementation. So then when we look at the Git log after we finish the rebase, we'll see that we just have 2 commits in this case, but the initial implementation commit actually has a fix now. So that's another faster way to do that, especially if you don't care about editing the commit message. Next up, we have exec. This one is super cool and one of the most advanced commands that you can do in interactive rebase. The way this works is it works a little differently than renaming pick to the initial command. And what I mean by that is, let's say that we want to execute something here after this particular commit. What we'll do is we'll type in exec, but then we'll give it a command that it can actually run. So what this is going to do is during the interactive rebase here, it's going to go through the first commit, the second commit, and then it's going to hit that execution, and it's going to just print out that message which says this is an example script. Kind of silly. I know it doesn't do a whole lot, but that's exactly what exec is doing in that case. And what's really nice about this is with exec, you can do more advanced things. Like this is a simple example, but imagine if you had a bash script or maybe some Ruby code that you want to run. Maybe you want to rerun your tests between each one of these commits during the rebase. Now you can do that by throwing in these exec statements and let Git do a lot of the heavy lifting for you. Super, super powerful. And along those lines is another command called break. It works a lot like exec, but it actually doesn't do anything. It's more like a debugger statement. So same thing as before, we'll figure out which commit we want to break at. we'll put a break command after that. And in this case, what the Git Rebase Editor is going to do is it's going to go through those first 2 commits, and then it's going to halt at the break and just kind of hang out until you're ready to do something. It's a nice way to kind of go back in time, almost like a debug statement in your Ruby code, but allow you to debug during the rebase of your commits in your feature branch and just hang out at a particular point in time and just run some tests, maybe add some new code, play around in there. And then when you're finally happy and satisfied, you just do git rebase continue and then finish the rebase. So kind of a neat trick to have in your back pocket if you ever need to do that. The last one of all these commands is drop. And it is pretty simple, pretty intuitive, which is we'll just pick one of these commits that we want to actually delete and kill entirely. And we'll just change it to drop. So in this case, let's say that we don't care about the table of contents. Maybe we realized after we added the implementation and fixed the JSON schema that we actually maybe don't need the table of contents. So we'll just delete it completely. And that's what drop does. The other thing, by the way, that you can do with drop is if you don't want to type this out all the time, you can actually just delete that line entirely. So what that means is if you delete this line entirely in the Git Rebase Editor, Git will actually interpret that as a drop implicit and just delete that commit entirely. I point this out as a nice technique to drop commits, but also don't go crazy in trying to delete commits that you don't care about, because those will actually physically delete your commits in your feature branch. So don't do that. And what that looks like, again, if you do a git log, right, of those commit messages, you'll see that we just have the 2 commits and we deleted the middle commit there. Okay, so we've gone through all the commands, right? Let's talk about Git Rebase Resolution, the things that happen when you are rebasing, but you maybe have a merge conflict. Let's take a look at that together. So the first thing you can do when you're rebasing is you can always abort. This is basically your escape hatch, your escape lever, right? You start a rebase, you run into a merge conflict, and you start to kind of freak out because you don't really understand what to do, or it's too complex. Maybe you just need to catch up with your team. Maybe it's your first time rebasing and you're not really sure what's going on, and so you just want to go back to where you were to begin with. So if you do a git rebase abort, that just rolls back the rebase as if it never began to start with. So this is your escape hatch, a really good command to have around if you ever get into a situation like that. The other one is git rebase continue. This is the one I've been talking about all the time. When you're in the middle of an edit, in the middle of a break, middle of a merge conflict, after you resolve any of those, you're going to want to continue with rebase so it can kind of chunk through the rest of those commits that are on your feature branch. The other one is skip. So in some cases, right, you'll do a rebase and there'll be a conflict resolution, or maybe rebase halts because it thinks there's something to do, but there actually isn't. You'll see that your command line is empty. It'll say something like head or no head or something like that, I think. I might be wrong on the terminology. But there's really nothing for you to do. So you can just be like, oh, okay, git rebase. You can go ahead and skip this and continue on with the rebase. And that's why you would use that command. The other one is actually recently new, well, relatively speaking, depending on how many versions back you are of using Git, is show current patch. I love this one a lot, actually, because sometimes if I'm in the middle of a deep rebase, I might kind of forget where I was. And so if you do show current patch, that'll dump out the status of where you are in the rebase. It'll show you what commit you're on. It'll give you a diff of what's changed. And so you can kind of pick up to speed really quickly as to where you are in the rebase. You can also use git status, by the way, to do the same thing, but I find this to be a little bit more informative. So FYI, you can do it either way. So we've gone through the conflict resolution, but let me show you a couple additional advanced commands, or techniques anyway, to kind of add to your Git Rebase workflow. The first up is fixup. Again, remember, I'm a huge fixup fan, so this is another way to kind of tackle fixups on your feature branch. And the way that works is you just do git commit like you normally do, but this time you pass in -- fixup, and then you pass in the SHA of the commit that you want to fix. So what does that look like? Well, if we do a git log of our current commits on our feature branch, right, we'll see we have the same three commits again. But this time we're going to make some fixups to the initial implementation, right? Maybe off screen, right, we added a new file or fixed up the implementation a little bit, and then we're ready to commit that. When we commit it, this time we'll say fixup, and then we'll pass in the SHA of the commit that we want to fix up. And then let's say that we want to fix up the README too, right? Like the table of contents were wrong for some reason. Well, let's make some changes to that. Let's regenerate that table of contents and start to commit those changes as well. But again, this time we'll say fix up and then pass in the SHA of the commit that we want to fix up. So what does that look like in the interactive rebase? We'll go ahead and do an interactive rebase off of master, assuming that master is still your parent branch, right? And what that'll look in your editor is you'll see something like this. You'll see your commits, and then you'll see your fix-up bang commits. I'm doing something special here where I've taught Git to automatically put the fix-ups with the SHAs that they're trying to fix. By default, all those fix-up bangs would be at the very bottom of this. I'll show you how to turn this on in a little bit, so bear with me. But the way that Git's doing this is it's saying, hey, fixup bang is a special directive. And the way it matches it is by the subjects. So as long as the subjects haven't been reworded, Git will automatically figure out where the fixup goes by the subject message. So the reason I point this out is you don't necessarily want to do a reword of a commit while you're trying to fix it. So just FYI, try not to do that because Git will get confused because the subjects won't match. So if you want that auto sorting, this is the way to do that without, just make sure you don't reword the original commit. And again, this fix up here, right, again, is nicely associated because the subjects match. It's kind of not too sophisticated the way that Git's doing this, to be quite honest. But that's exactly how it sorts those fix up bang commits. So when we complete that rebase now with those fix ups, right, everything looks good. We save the editor and let rebase do its thing. What we're going to see is we just have those 3 commits, but this time the initial implementation and the table of contents have been magically fixed up. And when you go to push this up for code review, your team members would be like, wow, I mean, you just write things, perfectly from the very beginning. Like I never see any problems in your code. Well, this is one way to kind of sweep that under the table and have a nice Git history. So the other thing you could do along those lines of fix up, right, is you can also do squash. I won't walk you through all this, right, because you kind of understand how squash works at this point, but I just want to point it out that it works the same way as fix up, but the directives are a little different. So again, we'll have our 3 commits, and let's say that we want to squash a couple of these. You pass in the SHA just like you do with fix up, same flow, and then what you're going to see is instead of fix up bang, you're going to see squash bang. That's the only difference. And again, they're associated by subject here. And that's how Git associates it. But the thing that's different with squash, remember, is Git's going to halt at this point and say, hey, look, what are the details of these commits? How do you, I'm going to merge these 2 commit messages together. Do you want to edit or change any of those? I won't show you all that, but just that's what would happen. You'd have an extra step here with squash versus fix up. And again, they're just matched by subject. And so that's fix up bang and fix up squash. And there's one last thing you could do with commit, which is amend. You might actually already be aware of this. It's pretty common. Most people that use Git to begin with actually understand this command, but let's talk through this and maybe show you a few things you might not be completely aware of. So when you amend a commit, you're amending the last commit made. That's all amend does, is it just gives you a nice way to go back and amend that last commit. Well, if you don't want to edit the commit message each time, you can pass in --no edit. And that'll allow you to just make, some implementation changes and then just throw it into the last commit, just amend that last commit. But you don't want to change the commit message because there's nothing really new to say, right? This will save you some time. The other thing you can do is you can do all. The reason I point this out is it is a little dangerous. Don't go hog wild with this because you don't want to just take all the changes you're working on and throw them into the last commit. That's not good. But if the changes are related to the last commit, right? If you've changed like the implementation and the spec, again, a very atomic commit, then sure, you just want to grab all those changes and throw them into the last commit because it's all part of the atomic message that you're trying to capture in time and then eventually share and review with your team. So we kind of walked through all of the rebase stuff. Let's talk about a few last tips before we kind of start to wrap this up. So I've been talking about how to rebase in your editor has a bunch of things it can do for you. Well, the first is you can set your Git config so that you abbreviate the commands. So when we were typing out like reword and pick and drop and so forth, if you just want to type, P for pick and R for reword and D for drop, you can have Git automatically abbreviate those commands so it doesn't spell it out for you each time. Really handy, especially once you get comfortable with Git Rebase. I highly recommend turning this on. It'll just save you a ton of time. The other thing is auto squash, and that's what I was talking about earlier. When those fix-up bangs and those squash bangs were magically put to where those subjects matched, this is Git doing that for you automatically. Otherwise, you'd have to physically move those around yourself. So I highly, highly recommend turning this on. Just let Git do all the work for you. And then the last one is auto stash, which is one of my personal favorites. And what that does is when you're starting to do a rebase, sometimes you might want to rebase, but you have some files and artifacts in your Git history that haven't been committed, or maybe you have staged them, but you haven't committed them yet. Well, if you do a rebase, Git's going to not prevent you from doing that, because it's going to say, hey, look, you've got some changes here that are not committed. What do you want me to do with those? And generally, you would stash those yourself, do the rebase, and then pop the stash to get back to your working directory. Well, with auto stash, Git will just figure that out for you. So you'll start a rebase, it'll detect that you have a dirty working directory, it'll put it into a temporary stash, do the rebase, and then when the rebase is done, it'll pop that stash for you and just put you back to right where you were working. So I highly, highly recommend turning this on too. It'll save you a ton of time, and it makes the workflow really, really fun. And again, just like before, these are the command line arguments that you pass in to turn all these commands on for your global Git configuration. The last one I want to wrap up with is re or rear. I'm never really actually sure how to pronounce this, but you also want to turn this on. And the reason I recommend this is not only is it good for a rebaser, but it's also good for somebody who just practices the default merge flow, because it's a way to record conflict resolutions. So the first thing you want to do is turn it on. Highly, highly recommend turning it on. And then the second one is to do an auto update. And what auto update does is, when you're in the middle of a rebase or a merge conflict and you resolve the merge conflict, what rear is doing is it's recording that patch diff and saving that, just in case you do a rebase again, it sees that same conflict resolution, it'll just automatically apply it for you. It is a huge time saver and a wonderful thing to turn on. So I highly recommend turning that on. The auto update then is another way to level up even on top of that, which is when you hit that conflict resolution, but there's been a slight change and you need to modify that just a little bit further, it'll save that delta and record that as well. So again, if you do a heavy rebase and you're hitting that same merge conflict each time, it'll just apply all those changes for you. Really, really cool. I'm kind of simplifying it there just a little bit, but that's what re is really doing. And again, these are the command line arguments to turn this on globally. So that's Rebase in a nutshell. There's a lot to dive into that. I had a ton of links in there that you can actually dive into, screencasts, tutorials, everything. But there is one thing I want to talk about that is Ruby related, which is GitLint. It's a gem that I have open sourced and been maintaining for quite a while, actually. It's gone through a name change. So it's same code, same implementation, just a different name. It's a way to actually kind of be your coding buddy, to hang out with you and help you make sure that your commit messages are up to a good high quality standard, so that you can keep yourself looking good as a professional engineer, but also help the quality of your team, right? You can actually use GitLint as a CI tool as well to lint and enforce a standard for your entire team, not just you, but your entire team. The way it works is and there's a ton of features on GitLint, so I won't go through all of them, but it'll check and make sure that your subjects are properly prefixed. It'll make sure that you have proper punctuation, which really actually you don't want any punctuation if you can avoid it. Make sure that you have a space between the subject and the body, and then make sure that you have a 72 character column count in which to wrap your words, so that you don't have this horizontal scrolling going on when you're trying to review or read somebody else's code. Like I said, there's a ton of features in GitLint. It's really easy to install. It's just a gem, just gem install it. Then you can switch to your feature branch and you can analyze the commits. You can also set it up as a Git hook locally, so that Git hook will just kick off GitLint every time you commit changes to your local feature branch. Again, really handy as a coding buddy, or you can set it up as a CI tool in which it checks every feature branch that everyone on your team pushes up for review. So what are the next steps? Now that we've kind of talked through Rebase and GitLint and how to kind of keep improving this workflow. Well, some of the things you can do is just start by practicing this each day. I know that it's a little daunting at first when you first start out with it. Like I said, Git is an obtuse tool. It's not extremely user-friendly at first, but once you start to kind of get that workflow into your daily ritual, it'll get easier each time. It's just like exercising a new mental muscle, right? Each day gets better and better and better. You can also add aliases to your dot files. I have a link here to my dot files if you ever want to check out my aliases, my functions, all the stuff that I use to basically just type a few characters to do all my rebasing. This is a good place to start. And then, of course, check out GitLint and let it be kind of a coding buddy and a guide for you to level up your coding skills, or your Git commit messages for that matter. And that's it. That's kind of the Git Rebase tutorial and workflow in a nutshell. I hang out on the Alchemist Collective. It's a collective that I've been managing for a while now. It's all about just sharing this knowledge, being able to level other people up, and having a community in which people can hang out and just learn from each other. And again, these slides, all the open source stuff, all of the tutorials, they're all on this site. So there's tons of stuff that you can check out if you want to. But yes, thanks so much for letting me speak, and so I'll just we have two questions
from Matt Reimer. If you have any more questions, drop them in the Q&A section. We'll start off with a thing that I noticed as well. You used a git switch rather than git checkout. Do you want to go into maybe the differences between those two commands?
Yes. So git checkout is the traditional command to use to switch between branches, but it's been kind of overloaded. Checkout does a lot of things. It does branch management, but it also like checks out commits and does other things that are not related. And so what the Git team has done, I think it was in Git 2.23, somewhere around in there, they switched it so that they split it apart so that you could do a git switch to switch and just focus on branches. And then another command, which is called reset, which allows you to reset or unstage commits. And so they split out checkout so it doesn't do all those commands. They split it out into two separate commands.
So it's more about you just wanting to be precisely clear about what you're doing rather than using the overloaded command. Cool.
Yes, and the goal is, I think the Git team's goal is to eventually deprecate checkout so that it's just not there anymore.
Another question from Matt. He says, when you're doing all this rebasery, are you only modifying your local uncommitted changes, or are these changes also rewriting the history on master?
No, when you're rebasing on your feature branch, it's only changing the SHAs on your feature branch. Technically, you can switch over to master and start rebasing and changing those, but please don't do that. It's changing the SHAs, and your team is going to hate you. But when you're on your feature branch, totally fine. It's just changing the SHAs on that feature branch, and then when you're finally ready to push that up, you'll do that push with lease, and you push it up to your feature branch.
And then Eddie has a question. What editor do you use to modify the rebase action / commit list?
Yeah, so I'm kind of old school, I guess. I'm still using, well, actually, I'm not that old school, I suppose. I'm imagining there's probably some Emacs guys and some Vimmers here. I use Sublime with Vim mode enabled, but it just pops up into Sublime. So I just set my global editor variable to point to Sublime, and then Git just picks that up. So that's how to do it. Yep.
I believe that is it. So thank you for this wonderful talk again. You said you're going to make your slides available?
Yeah. Wherever you would like me to post them, I'm totally happy to post these wherever you would need them. Actually, I can put them into the Slack. I'll just put them into the Meetup Ruby Slack channel. Yeah.
Cool. Question from Matthew Reimer. Coming in at the end, Matt. Is alchemist.io a website, a Slack, or how would I engage in your community?
Yeah, so it's still early days. I'm trying to. I do have a Slack community for it. So there is a Slack team. I don't have it's really just my wife and I at the moment, but I'm trying to kind of build up interest and try to build a collective, right? A community in which to really dive into these deep issues. And so I do have Slack. I also have a Twist area. If you're familiar with the Doist team, it's kind of an alternative to Slack, more long form thought, which is really cool. And then there's all the open source stuff, and then just the site itself. So I actually am working on web mentions, so hopefully I'll get that up on the site too, so that we can all use open source and open web to actually communicate that way
Very
too.
cool.
So,
One last question
you know,
here,
baby steps,
also
piece by
asked
piece.
from Matt. What's your perfect Sunday?
Perfect Sunday. Oh man, these days it's usually just you know, just getting that chance to, you know, wake up in the morning, grab some tea, and really just hit the books. You know, like either I'm trying to learn something else or I'm tinkering with some other problem or idea in my head, and I just want to scratch it out in the morning and just have that free time and that flow, that development flow where you're totally uninterrupted, nobody's bugging you, and it's just pure joy to kind of solve a cool problem or find a new way to solve something very
Cool. Well,
elegantly.
as a coffee drinker,
So
how
that's
dare
kind of
you
my
drink
Sunday
those
morning.
3 leaves? But thank you again for your talk. I know I'm going to be revisiting this video a couple of times and probably pausing several times to read all of the associated links and things. And so those slides are definitely going to be a really good addition to our collective knowledge base here at Edmonton. So thank you for your contribution to the meetup and all this stuff.
Oh, oh, thank you. Yeah, you're most welcome. And like I said, those slides have the links, and there's some really cool tutorials that just kind of do an ASCII screencast of walking through each one of those
There's
in
even
more
more detail.
detail. So
Excellent.
hopefully that'll be of great use to you. Yeah. Yeah, unfortunately, I wish Git was a little bit more intuitive, right? A little bit more friendly, but it really is obtuse by default. Yep.